Hello, my name is Ken Wysocki. I am the utility director at Emory University, and we are presenting today with Chris Angerame from utiliVisor.
Yes, I'm Chris Angerame. I run our operations center here in New York City, and I'm the vice president of engineering.
And the presentation today is basically talking about the relationship that Emory University entered with utiliVisor to basically answer the question of, can data oversight and action result in enhanced operations and optimized plant performance, particularly for our chiller plants. So the overall kind of the summary agenda for the presentation that we're going to go through today is bullet pointed here, and ultimately, initially, I'm going to go through kind of a description of how the Emory campus is set up and how our operations and maintenance for our chiller plants is set up. Let's talk about a little bit of the culture that we have here at Emory University, and then some of the struggles and operational constraints that we have, some of our future challenges and planning for expansions that we have. And then Chris is going to talk specifically a little bit more about the relationship that we entered a couple of years ago and how we have been able to use that relationship to further improve our operation and performance here at Emory University. So the Emory campus is set up where we do not have a centralized chiller plant like some campuses and facilities. We have basically three major chiller plants that are shown here. We've got about a total of about 20,000 tons of cooling capacity. And a majority of that is the three major chiller plants. So we have a W&B chiller plant with 6 chillers. We have quad chiller plant with 4 chillers. And then we have a Michael Street chiller plant with 7 chillers. We also have on the steam side, we have 5 boilers. We do have a centralized steam plant that serves the whole campus. And there's about 500,000 pounds per hour of steam capacity there. And we do have a 1 megawatt steam turbine as well. We go to the next slide, kind of just the physical layout of the plants. As you can see from here, the Michael Street chiller plant is kind of an island unto itself. It's on the north end of campus there and serves the buildings on the north end of campus. The W&B and quad chiller plants, they are cross-connected, so we can utilize some for both reliability reasons and efficiency reasons. We can transition cooling from one plant to another. Since those cooling systems are interconnected. And then our steam, like I said, we have a central steam plant that's shown there, and that pretty much services all the heating needs throughout the whole campus as well. So a little bit of background for how our manpower is set up. Previous to about 6 years ago, the chiller plants, the centrifugal chillers and the operation and maintenance of the chiller plants was done out of our centralized HVAC shop. And about 6 years ago, it was seen that they weren't getting the attention and the operators for the chiller plants weren't as knowledgeable. So it was decided that we would start a separate group just focused on operating those bigger centrifugal chiller plants outside of the HVAC group, which was more focused on building HVAC. So we have 3 operators, and those guys were both for operating and maintaining the chiller equipment. So it moved us more towards focusing on those specific pieces of equipment and trying to make them more reliable and more efficient in improving the knowledge of a select group of people to run that equipment. However, because of that, the guys that we had initially, we had 2 guys out of our HVAC shop, and we hired in an additional person. Most of their background was in general HVAC. It wasn't necessarily focused on chiller plant operations and maintenance. So there's definitely a gap in knowledge and experience in those individuals as we started that process. So that was one of the initial hurdles that we had. We also had an initial hurdle of just only having 3 guys to run that big of a system. Definitely had its challenges as well. So part of the culture and some of the things that we're working with here is, number one, is trying to, motivate our staff and showing them that, the things that they do that have positive events and they can take action on stuff, and having the confidence to take action on stuff. Because up until now, because of that lack of knowledge and the lack of manpower that we have, the focus is mostly on not efficiency of the equipment and the plants. It's more of just keep things running, make sure we have the capacity online, make sure that we don't impact our customers. So it's more about just keeping things running versus trying to keep it running and as efficient as possible. So, another obviously issue that we run into is, because of that operational knowledge and experience, or lack thereof, there's a lot of misconceptions about how to run chiller plants, and when troubleshooting, what things can you do. And so that is one thing that we continually run into is the tribal myths around chiller operations in some of the inexperience there. So we have been working with our folks and to try and improve that education, both in source training and sending them to different classes and stuff to gain that knowledge, besides operating the equipment on a regular basis. One of the other things that our guys have struggled with a little bit is KPIs and data. And so we have control systems. They aren't set up standardized from one system to the next. A lot of the information is not necessarily easy to find and isn't consolidated and isn't standardized. So just getting our guys to be able to talk in KPIs and data is something that's difficult to do because we don't have our systems set up that way. And our guys are also, they're comfortable and used to looking at machine efficiency. So how a particular machine is running, but then when you take a look at, or try and take a look at total system efficiency, they struggle with that because it's just not something they're used to. And it's not something our control systems have been set up to show, overall plant efficiencies with all the equipment and all the chillers and how they're sequenced and how they're running. And then ultimately, so we're looking for trying to find ways for these guys to push the efficiency improvements and see the results and be confident in those results. Talked a little bit about some of the constraints that we have based on that, but to touch base a little bit more on some of the additional constraints that we have here on the campus is, like I said, understanding performance from a holistic standpoint, not just from plants as a whole, but then how they interact together. So I mentioned earlier in the presentation about the quad and W&B plants being cross-connected. So trying to understand what is the correct way to operate those plants, not only individually performance-wise, but together. And so we don't really have a lot of good indications and setup prior to working with utiliVisor on showing that overall efficiency of, depending on how we made moves or how we would flow some water from one system to the other, to try and understand if we were doing the right thing from an efficiency standpoint. And then also a lot of the control algorithms, and touched on this, but most of our controls are Siemens building controls. And I would say that a lot of the control focus was more on the building HVAC as a whole, and to some extent, even I think some of the controls for the chiller plants were kind of an afterthought. So just validating the strategies and sequencing that we have around Our current programming is something that internally, not only with my operators, we don't have the experience and knowledge to necessarily question all the time, is the current sequencing and controls that we have in place, is that the best for our system? Is it the most efficient, or is it just, hey, it's keeping things running and online? So that's one of the things that we struggle with, is just being able to, if we run into a problem, we don't have the knowledge in-house to be able to question it or dig through it and try and get the right answer. And that goes along with, next thing, the tribal myths and methodologies around operations. We have guys that, like I said, have HVAC background, but they don't have chiller plant background and knowledge and experience. And even though we do have some engineering on site, once again, they're not necessarily involved day to day with the chiller operations, and their focus is not completely on chiller operations. So my guys struggle a little bit with, hey, if things are operating in a certain way, trying to dig into the details of what is the true way that it should run and operate to be the most efficient, because we just don't have that in-house knowledge and experience. We have put in some investments over the years, obviously both on chillers and pumps and fans on cooling towers to install VFDs. So that's one of the things that's always a question mark is, are we making the best utilization of those VFDs and the savings that we should be able to achieve on those. So we don't necessarily have anything in place to validate that as far as efficiency of operations. And then ultimately communicating to the non-technical people on the campus. So whether it's making investments in our chiller equipment, repairing our chiller equipment, or making changes in the control sequencing, is being able to effectively communicate that information with our the rest of the campus, with our non-technical people that don't understand anything about chiller operations. And they just understand, am I hot and cold, or am I spending money from my department to the utility department to make changes and put capital. So then also being able to effectively have data to show, when we make investments and when we have changes, that then, those changes are actually driving savings and improving our spend. So talking a little bit too then about, okay, that's our current kind of setup. That's kind of where we were. And one of the reasons why we got in our relationship with utiliVisor is to try and help us get through some of these, internal hurdles that we had, and try and get past some of these internal constraints. But also, we do have a healthy CapEx here at Emory campus, and one of the things we want to do is make sure that we're using that capital money in the most efficient way and spending it on the right things. So that's another constraint for us, is trying to make sure that we understand the best way to spend the money that we have. And so, working with the utiliVisor folks and trying to look at where our issues are and trying to spend the money to help us fix the most important things. But based on that too is we have a current capital plan, and here's some of the things that we have been doing recently, and look some of the things that we're looking forward to doing in the near future. So just as a kind of a quick go through, last year we recently, one of the standalone systems that we have, because we have a couple of standalone building systems, is we replaced the centrifugal chillers and the backup air cooled chillers for our overall the building that serves our overall campus network. IT computers is mostly in one building. So we recently upgraded and replaced that whole system. So it's brand new. So we don't have any reliability concerns around the cooling for our computer network system here on campus. We're currently right now replacing 3 of our 7 chillers at our Michael Street plant. And the 3 chillers there were our oldest chillers. They were also R11 machines. So we're looking at not only getting rid of our older inefficient machines, but also trying to get rid of the older refrigerants that we still have on campus, because we still have some is this R11 and R22 machines on campus. And then also this spring, we have 2 brand new buildings coming up online. Our health science research building is coming online. It's got its own standalone system. And then a new Rollins research building is coming on, and that will be connected to our Michael Street chiller plant. And then a couple other things in our 3-year plan is we're looking at fully automating that cross connect between WMB and quad. Right now, the cross connect can go one way, but then to switch it back the other way, there is some manual intervention that has to take place. So to try and once again improve our controls and efficiencies, we'd like that to be fully automated so it can go back and forth depending on what the need is at the time to try and improve our efficiencies as far as running those 2 systems together. We're looking at, I mentioned earlier that most of our controls are Siemens building controls. We're looking at switching to heavier duty industrialized controls, and it gives us more flexibility as well. So we're looking at upgrading all our chiller plants to Rockwell PLC controls. So that gives us additional flexibility and capabilities, I believe, there. And we're looking at improving our campus master plan once again for just our chiller systems. Looking at, where do we most effectively spend the money that we have to get the biggest bang for our buck. And then ultimately then too, we've 3 years ago, we replaced 2 of the chillers at our WMB plant. We're currently replacing 3 chillers at our Michael Street plant. So we're looking at additionally replacing a couple of chillers at our 3rd major plant, the quad plant, sometime in the near future as well. So overall, kind of circling back to, Chris is going to start talking here specifically a little bit about what things have we done with utiliVisor recently, details more on those specific improvements and savings, but just, concerns and, like I said, why we entered this relationship with utiliVisor to begin with, and have seen a lot of benefit from it. But, what things we were experiencing and why we entered this relationship is, one thing I obviously said to capital spend, where do we spend the capital that we have? Where are issues that, rather than just going with, hey, these are the oldest machines and we should replace them, where do we spend our money to get the best benefit? So having someone help us identify that is very important. Utility production, once again, I said previously, just because of the knowledge and experience in-house, we were focused on just keep the equipment running, make sure we're reliable, make sure we provide the cooling for our customer. That's obviously number one goal, but then ultimately our job here is to reduce our costs, save money for our campus customers, and be the most efficient, lowest cost utility that we can be. So internally, we struggle with that, both from a data side and from a knowledge and experience side. So getting in this relationship to try and help us focus, now that we have a good feel for how to make sure our equipment is reliable. Now the next step is, how do we be the most efficient operation that we can be, is where we needed additional help. And then identifying any additional incentives, as far as there's a lot of different things out there incentive wise that we can help to improve our costs and performance. So identifying those where we can. And then one thing I learned a long time ago is you can make all the improvements you want, but if you don't continually look at it, manage it, validate it, and ensure that those performance improvements that you've made are, in place and continuing to provide you savings, then you'll very quickly, within a year or so, I've seen it happen, you will go back to where you used to be before. So the continued relationship with utiliVisor, is going to continue to help us to solve that problem and help us maintain that focus and that information on where we made savings, continuing those savings along. So that's kind of the overall back of Emory University, where we're at, what problems we're facing, and why we got utiliVisor involved with us in the first place. And Chris now is going to go a little bit more into the details of what we did and how we accomplished it.
Sure, and I just want to note, I mean, based on when Ken talked about being short-staffed, it's amazing what he and his team are able to accomplish. With the 3 engineers. Just the campus footprint itself of how much water gets distributed to these buildings is amazing. And, the relationship that we have with Ken and his team, they would call us up, they would try something out right away, and we would be able to validate it and show the savings. And I think what was pretty interesting too is some of the offset smaller buildings. They took it upon themselves to even implement the same knowledge that they learned from the bigger scale plants to the smaller plant. And, they were all about it. They wanted to see how much money they were going to save and, how much more they could push the system, which was really pretty interesting. So looking a little bit at the energy plant oversight, again, we really get down to that granular data. We'll talk about it in the next slide, but, most of the points that we gather are every 5 minutes from the BMS. And, typically our processes will start from the plant itself, looking at profiles of how the plant relates to load, and then looking at the largest consumers first, like Ken said, what are the different chiller staging techniques, and then even going down to then the pump curves. So again, we make recommendations, everything from revised reset schedules as it relates to weather. And it's a test case scenario where there's engineering theory where everybody knows that these are where certain set points should be. But again, every plant is a different animal here. And as the plant gets upgraded with drives, again, there's a lot more seasonal adjustments that you make and that can really squeeze out more savings. But again, you have to worry about where, if I'm saving energy at my machine, am I costing too much maybe now at another piece of equipment? So that's something that we continually refine over time. And again, kind of what Ken said, stuff tends to drift over time where, even new machines, when you get them, you have your performance standpoint from the manufacturer, but, over time with heat transfer or, different approach temperatures, that's going to fall out of line. And again, it's something that constantly needs to be monitored and noted. And again, we talk a little bit about, graphically explaining it, because again, a lot of it is a lot of data oriented, where sometimes, I always laugh, these scatter plots can get lost, if you're really not familiar with them, where they just look like, a million dots on a piece of screen. But again, from us, understanding those outliers really shows where the potential for savings are. And again, relating everything to we talked about efficiency metrics, kW per ton, pounds per ton, but even putting then that cost per hour. So everybody then will understand, what the benefits are and then what the ROIs are for the recommendations that are being made. Again, Ken and his team, they have a lot of systems on campus. So, one of the things from our data collection standpoint is that we're bringing in those 3 systems and then actually syncing all those timestamps together. So we do have the ability to overlay all those systems. So if we say something in a chiller plant where we want to make some type of DP adjustment, then from the data that we're getting from the valves within the loop, if that's on another BMS, we can sync that over that, just so make sure we're looking at everything holistically. This is just a screenshot of our application. We try to mimic the BMS a little bit at the top left corner, where you have a nice overview of all the equipment that's operating. So all the data that's being sent of us in 5-minute intervals gets sent in our data collector, gets scrubbed, so that way you don't have any spikes or null data. And everything, like in specifically, if I'm looking at a chiller, all the data that I'm getting from the panel, so the power input, data from the flow meter, the temperature differentials, refrigerant control, that's all being then analyzed by our team here, normalizing for, what time of the year it is the machine part loaded? And again, is it meeting the criteria that the manufacturer set? And can I also do a little bit better? The one benefit is we have an enormous amount of data on a lot of machines throughout the country. So, we might have another, 1,200-ton chiller, in New York, where we know that it can even do better than the performance. So we're constantly, judging the performance from the vast amount of data that we have here. And just in the bottom right is, everything is, we analyze the performance, and then when we send a recommendation to Ken and his team, we try to describe what the problem is. Again, these guys are running around doing an enormous amount of things. They don't have time to read, a 5-paragraph email. So we try to condense it into something that everybody's going to understand, to say, okay, maybe let's make this differential set point change, where let's run the smaller pumps. We're expecting this much savings, and then this is what the ROI is going to be and how long you can actually do it for, and then put a cost aspect to it, which I think is helpful for everybody. So out of the 3 main chill water loops, we focused on the standalone plant first, which was the Michael Street, because, again, kind of what Ken was saying before, with the other 2 plants, there was an interconnect and they feed a lot more buildings, where we just wanted to focus on somewhat of the simplistic system first, because we actually were collecting a lot of the buildings that were connected to this chiller plant loop, as far as valve positions and actual individual flows to the buildings themselves. So just from our process itself, we always want to know how the chiller plant relates to certain components. Again, weather always is a big one, where especially being in Atlanta, you always need to consider both the humidity and the dry bulb. Again, because it's a university, scheduling is super important, Monday through Friday and time of day. We also then take that profile and see how the plant total consumption relates to it. So all the power that the cooling towers, the pumps, and the machines consume, overlay that, and then add the metric for cost per hour and/or cost per ton. We take all that interval data, and we then, use a statistical software to actually build relationships. That way, when the engineer makes a change, or wants to know, what the expected load is going to be, 5 days from now, and how he's going to stage his machines, that's all built in real time in our application. I know I talked about this a little bit before, but when we look at these large data sets and scatter plots, it's really the outliers that we kind of first zone in on. Simplistically speaking, is that typically you always want to see a nice linear relationship to the amount of cooling that you have to the power that it takes to cool those BTUs, or those ton hours. So anything outside that may indicate, maybe you're running too many machines, maybe you're running too many auxiliaries. And then in this specific case is that, there was a lot of bypass flow that was happening, because the engineers were trying to meet the differential of the loop itself, and also, they wanted to make sure they were supplying the cold enough water from a chill water standpoint. And then, they did had some basic reset schedules, which actually we improved again based on the season themselves. So I'll tell you, it's, everybody can talk about efficiency metrics and KW per ton, where this actually was a little misleading when we first started collecting data, because at the part load conditions, the efficiency actually seemed really, really good. The plant was running a little bit of a larger machine that was the most efficient compared to some of the smaller ones. But what we noticed is that the load was a lot higher at colder temperatures. And the reason being is that they were bypassing so much more water, because basically they had too much muscle. So if I was an engineer looking at the BMS, I would be misled, because I would think that overall efficiency is basically beating the standard, where I would think that I'm good. But actually, what we found out was, even though you operated a smaller machine and it was a little less efficient, grand scheme of things, because now you were producing less tonnage, you had less KW overall, and your cost was a lot less. So just getting into this graph is a lot here, but again, this is just a sample of every single data point that we take in. And again, normalizing it for that outside air temperature, for the year, for the month, the season, time of day, when the building is being occupied. If you actually look in the top left corner, you can see that the blue line was our base year of when we first started collecting data. The load was significantly higher than the green. So the green is when the plant implemented the recommendations, started running the smaller chillers, started operating with the lower differential pressures. And if you kind of scroll to the bottom right here, you can see actually the efficiency was a little worse. It was a little higher at 0.8, but I'm consuming a lot less power, and the plant saved an enormous amount of money implementing this ECM. So once we got confidence from the team, they implemented all those ECMs, then we expanded out to some of the cross connect plants. And again, same kind of theory, where we looked first at the chiller controls. In one plant in particular, they had a higher head pressure control, where, again, at those part load conditions, we wanted to make sure that you got the biggest bang for energy savings. So we actually modified some of the control loop where that head pressure control didn't open as soon, and the lift was reduced, so the chiller saved energy at those lower conditions. With the new machines that were installed, they also had drives installed on the condenser water pumps, and we were able to show, still within manufacturer specs, that we were able to save on auxiliary efficiency by lowering that flow slightly without any impact on chiller performance. And again, from another auxiliary standpoint, one of the plants has different cooling tower fan sizes. So we were actually able to show, with a little bit more surface area, you were actually better off running a larger fan that had a larger horsepower, because the heat transfer was better, and actually the fan didn't work as hard from the fan affinity loss. So one of the things that we see, again, Emory has an enormous amount of machines that are, various sizes, where, again, good practice is to constantly cycle the machines just so they're not sitting there for a long time. But again, looking at that data over the course of several months, they had an enormous amount of chiller combinations that at that same load, without any difference to what was being sent out to the loop, they were consuming a lot in the plant themselves. So this was just to show kind of the different variations, where you had 4 different combinations with 2 machines, you had 2 combinations with 3, and then 1 with 4. And this is kind of off topic, but sometimes a lot of people feel as though, I'm going to put a VFD on something, I'm going to save energy. And common engineering theory is, I'm going to run all of them, at part load conditions. But again, there's even a break point with that, where sometimes actually scaling back and reducing the quantity of equipment on drives is more cost effective. This was just an example, again, from the holistic standpoint. So looking at those statistical formulas that we create. So we create individual performance curves for each piece of equipment. So we know at specific loads, if I lower the condenser water temperature X amount of degrees, it's going to save a certain percentage for every degree lowered. So on the bottom left, for this particular machine, the engineering is around anywhere from 1% to 2% per degree lowered. But with these constant speed chillers, sometimes we see it a little bit less. And actually, this particular one, it was saved up roughly about a 1.5% for every degree. So again, getting better heat transfer with different cooling tower cells. We used a larger cell that we maintained around 70% flow. And we were able to say, okay, if you lower the temperature this much, we need to make sure that the cooling tower fan doesn't exceed, X percentage, because then it's a wash. This is just a sample of the monthly energy report that gets sent out. This is kind of really the report card for us, as well as Ken and his team, to show what the cost per generation is of chill water and utilities. And we break that level of detail out for every component and every plant themselves. So one of the items that we talked about is once we define the correct chiller sequence, and actually we noted some inefficient valve control that the HVAC team corrected. Some valves were scaled improperly, some were cycling. So in order to meet the load requirements, the plant had to work a lot harder. So over time, we were able to chip away at those inefficiencies of the campus buildings, which enabled the chiller plant team to now start cutting back on the amount of water that they had to send out. So this was something where, in addition to running smaller pumps at a little higher speeds, we were able to save nice chill water pump consumption that gets documented in our cost report. In addition to that, we also have alert thresholds where our team gets notified if a certain parameter gets out of our baseline for a certain amount of time. So this was just an example of something where it alerted our team to let us know, okay, hey, something isn't right here, where this has exceeded your baseline of efficiency. This needs to be looked at and addressed. So overall, to date, we've saved about 18% of chill water generation cost. Again, large part of that is refining how the load reacts to weather, increasing efficiency from chiller staging, really reducing that excessive bypass flow. Again, it was misleading because you thought that the team was doing very, very well with those nice increased efficiency numbers. But again, that additional load, caused them to consume a little bit more power. Auxiliary sequencing. Again, Emory has an enormous amount of variation from different size chill water pumps, cooling towers, even machines themselves. So really refining those and eliminating the overlapping was a big savings. And then constantly tweaking the system with seasonal adjustments. A lot of these air handlers are able to operate with outside air-free cooling. So when the temperature does cool down below those desired discharge set points, we were able really to cut back on plant consumption, which has really been nice. So again, I guess just the kind of collaboration moving forward is really helping Ken and his team with the new machines that they have on campus. Again, we've done this with a lot of clients where we want to make sure that machine is performing to exactly what the manufacturer expects, and really kind of go beyond that energy savings. And again, constantly working with his team to make those tweaks that we document in real time.
Yeah, one of the things I want to comment on that piece is as far as working with Chris and his team, my operators very quickly, because of the ease of communication with utiliVisor and with Chris and his team, they jumped all in on this. And that, I think that's one of the keys of success for what we've experienced is the willingness of my guys to take the recommendations that Chris's team has and implementing them, and then us looking at the results and tweaking it further from there. So, because this doesn't work, Chris can make all the recommendations he wants. If we didn't actually follow up on that and following up in a reasonable timeline too, none of this, we wouldn't have been able to develop any of these savings and improvements that we've had. So, kudos to Chris and his team for not only making the recommendations very easy to understand, working with my guys on the results of what those recommendations were and figuring out what the permanent changes were going to be. But them also, being available, being very easy to talk to, those kinds of things I think are, you talk about the data and how you look at the data and everything else, but it really breaks down to, what is the communication and collaboration with our team and with their team that really made this successful. And that one of the key components, I think, for what we've been able to do here. So in addition to that, just as further comments on my end, obviously because of the successful experience that we've had here, you've seen the numbers, you've seen the savings, but to moving forward, continue this collaboration with utiliVisor to try and meet our goals and to try and further the goals that we have for here at Emory campus. And so, some of the additional bullet points here on this slide, as far as moving forward, I did mention initially that we do have a centralized steam plant and we do have a 1 megawatt turbine on campus. So utiliVisor and Chris and his team have had the information on our steam plant. We haven't focused as much on trying to optimize the turbine performance and the steam plant performance as much as we had the chiller plants. But moving forward, we'd like to do more work there. Obviously, I talked a little bit about us upgrading 3 of the machines, replacing 3 of the machines at Michael Street. One of the things I was able to do is, bring Chris and his team in on the beginning of that and kind of talk about, as far as plant operation, what kinds of machines and what size of machines, as far as replacements would be, using their help and their technical knowledge to help us make the right decisions with that replacement. And so continuing to do that with projects moving forward is using utiliVisor as a technical resource to help us make the correct decisions with priority of plant projects, and also, some of the technical details of types of machines, size of machines, and that kind of thing. And then once again, a lot of knowledge and experience, and trying to continue to raise the level of my operators and their knowledge. And also just not necessarily that they have all the answers, but utiliVisor and Chris and his team, knowing that they have a good technical resource that they can bounce ideas off. They have questions, or as they are out there trying to figure stuff out themselves or troubleshoot something themselves, using utiliVisor as our additional outside technical resource, so that we know we have that out there that we can lean on if we need to.